Welcome back to the Automation Podcast. My name is Shawn Tierney, industrial automation content creator and instructor. And this week on the show, I meet up with Landon Descamps to talk about the applications he's working on right now in industrial automation. But before we get to that, I do have a couple of announcements. First of all, I want to thank Landon and his company for sponsoring this episode so we could bring it to you ad-free. I also want to mention that I do have a training class coming up. So if you're interested in some training by yours truly, please check out theautomationschool.com. And with that said, let's go ahead and jump into this week's episode of the Automation Podcast. Landon, welcome to the Automation Podcast. I'm excited that we're meeting today and the topic we're going to talk about. And I just love your background. You have a beautiful office and a training center there. But before we get into all of this, first, why don't you introduce yourself to our audience?
Sure. Thanks, Shawn. I'm Landon Descamps. I've been the owner of an automation integration company out here in Colorado. Been working in this field for close to 20 years now. It's a lot of fun. Absolutely, just a great time going around the country and get to explore old sites and old machinery and bring them some new life, upgrade them and bring them into the modern age the best we can.
Yeah, that's awesome. And you were telling me, tell us a little bit about, well, first of all, what's your company website? So anybody who's listening, that we can throw that out to them.
Sure. So you can find us at LandonDescamps.com. That's my full name spelled out, LandonDescamps.com. We've got some interesting previous projects and some of our capabilities listed on there, as well as some of our industry partners.
And for the audio audience who can't see what you're sitting in front of, can you explain the room you're in right now and what we're
Sure.
seeing?
This is kind of our main office and demo room here. This is where a lot of the programming magic happens. So I'm a big fan of multiple monitors. So what we're looking at for those of us that do have video, we've got 7, in this case, 8 monitors fired up. We've got a Beckhoff HMI in here to demonstrate some different functionality of the equipment we intend to talk about today. Uh, but yeah, lots of monitors, lots of prototyping area for spooling up different servos, some Schneider interfaces, some of their TSYS Island piece that we can demonstrate different functionality there, and a whole bunch of back off PLC equipment and safety modules.
Yeah, we haven't talked much about Beckhoff on the podcast, so it's great that we're going to do that today. We have had the TSYS Island people on, which was great, very interesting product. But let me just turn it over to you and let you take control of the meeting, and I'll just sit here as the audience and try to ask questions that the folks out there who are listening and watching right now would have.
Sure, sure. So I guess a great jumping off point for us, we came here today to talk quite a bit about energy efficiency and industrial automation. Something I think we both kind of felt was not spoken about enough, and certainly at the forefront of a lot of people's needs throughout different facilities globally, and especially here in our country, with some of the energy initiatives and other things that are available out there. So I think it's just a great topic to go over some of the different resources that are available and take a look at how we may be utilizing some of that stuff with equipment that we're working on, familiar with, and hopefully inspire some other folks to find ways that they may choose to utilize some of that equipment in their own projects.
Yeah, I found it so interesting when I got started back in 1990, having done electronics in school. And when I first got out of school, I worked on electronics projects, a lot of microprocessors. When I got into industrial automation, one of the messages they were always saying is energy savings, energy savings. And it had a lot to do with pumps and fans because a lot of pumps and fans would run 24/7 at full speed when they didn't have to. So let's jump into that. Do you do anything with pumps and fans and VFDs and soft control? Tell us a little bit about that.
Sure. Yeah. So a lot of the ancillary support equipment, one of our biggest, I'll step back a little. One of our biggest market segments is high-speed web manufacturing. So different paper, cardboard, web manufacturing equipment around the country. And although there's a lot of VFDs, motors, servos, that would have you supporting that equipment directly, some of the biggest energy consumers are actually large scale VFDs. So we've got 200 horsepower vacuum pumps and 150, 200 horsepower compressors, lots of ancillary equipment that's out there supporting that entire operation and multiple assembly lines or production lines with that equipment. And so, yeah, we do. We find ourselves there's a lot of old, outdated equipment out there that's missing VFD or a soft start, that's missing some of the potential energy savings. Where we've still got old-fashioned contactors that, certainly have to speak highly of the folks that were making those contactors back in the 70s and 80s because, gosh, they're still out there doing their job and starting these motors oftentimes, pretty reliably. However, there's not much energy savings or not much attention paid to proper etiquette on the grid, I guess we would say. So, when we're firing up these giant motors, 200 or 150 plus horsepower, now obviously there's one heck of a load being presented to the grid at that point. And that's where our soft starts and VFDs really come in to help, both with efficiency and with a little better etiquette as far as not just throwing the power company a curveball every time we hit the start and stop on it.
Yeah, yeah, and I think it's, it's something we do in our own lives with our own energy, right? A lot of times, if we need some supplies, we'll say, I gotta go. I need to go to the big supply store to get that stuff. And do I have enough on my list to actually make that trip? Because, it's time, gasoline, and all of that to make the trip, round trip. And so, we got to look at it when we're looking at our facilities, right? A lot of times the controls folks, they don't see the electric bill, but it is typically in a lot of plants is a huge pain point for the company. It's something they're always looking, just like at home, we're always looking to reduce our electric bills. And so, tell us about, any applications that you worked on recently that you can kind of dive into us and tell us about.
Sure. So we have a client down in Tempe, Arizona. They're actually a Broadway theater, and what they've got a very old overhead rigging system that operates 30 overhead hydraulic cranes. And the way that they've done that in the past is they have a huge 700-gallon hydraulic reservoir. They've got four massive 30 to 40 horsepower hydraulic pumps. And all of those pumps were on traditional contactors, just like we had initially spoke about. So every time that one of these 30 overhead cranes is needed during a Broadway show or some sort of large scale presentation that's happening in front of this live audience, we've got to instantly fire up this giant 40 horsepower pump in possibly as many as four of them in succession in order to operate all those overhead cranes. And part of what we had done years back, about 7 years ago, was went in and said, okay, at least let's step one, let's get some soft starts on here. Let's get a little bit more fire control over these motors so that we're not just slamming them on and slamming them off every time we start and stop. That was kind of our phase one with them about 7 years ago. Now, recently we've reevaluated all their equipment and said, okay, let's prototype a system where we directly servo drive it. So instead of having any hydraulics whatsoever, we can take and throw a servo motor on this overhead crane. Gives us a higher measure of safety due to the number of brakes involved in the system. Gives us more finite control, more precise control over the position of the crane, better operating speed, and then lastly, it also gives us the ability that they've never had before to actually recover energy. So by having that coupled three-phase motor or servo motor coupled directly to the load, it lets us take whatever load is currently descending or dropping back down to the stage and then run that through a regenerative circuit that can grab that power and put it back on the grid. So now instead of just dumping it into a hydraulic tank, that creates a lot of heat, and then we have to, counteract that heat with a chiller system. Now we can do away with all those things and actually reintroduce that power to the grid. So this one's pretty recent. This one is kind of in the demoing stage right now, but with purchase order pending. So hopefully by next year, it sounds like we're going to be rolling with replacing the subsequent 29 other cranes with a direct servo drive.
Yeah, and now that we're talking about too, sometimes we'll do the common bus on large systems to allow, instead of dumping everything to a break, a big bank of resistors, to allow some of that energy that, for slowing down high inertia loads or whatnot, to be used by the other VFDs on the system. And I know a lot of engineering goes into those types of systems. But like you pointed out, I can see hydraulics being a great way to do that, many years ago, but servos just giving you so much accuracy and, speed. And, I would imagine if I was in a theater and I was making a change during the middle of a play, I'd want something that was quiet and fast. And you see a lot of this down at the amusement parks down in Florida. You see a lot of servo-based control because, they don't want the audience hearing all kinds of, they don't want it to sound like a big, you know, uh, you know, uh, backhoe or anything like that with the hydraulic pumps. Yeah.
Yeah, absolutely. Yeah, you do. You hit on a great point there, Sean. One of them is that kind of common busing between these systems too. We don't always have to dump that power back to the grid. We can also store it and deliver it to other drives in the system simultaneously. So, like you mentioned, if we've got one load speeding up and one load slowing down, we've got those drives coupled. They can actually share in that power regeneration and utilize. Oh,
Yeah, absolutely. And a lot of times too, we use that to, we want to avoid that peak charge, right? So we go over what we're allotted by the electric company and we have to pay a lot more. We have to pay a peak charge. And I know down at one of the big theme parks is they actually use giant generators to spin up flywheels. And they actually use the flywheels to drive 100 VFDs to shoot the roller coaster on its way because without that, the energy it would have took would have been throwing them into that peak period with the electric company. And of course, electric companies they like everything to be nice and they want a constant demand. They don't want it going up and down, right?
yeah, yeah, absolutely. Yeah, it's a really cool kind of field that we're in now, or at least where this market has grown into over the past couple of years. There's a lot of vendors out there that are offering some really cool products within this field that help us do a better job of utilizing that energy. For a long time, it was kind of there was always some DC busing sharing that was capable between larger VFDs and stuff, but it's become, I feel, a lot more prolific over the last, say, 5 years or so. We've gotten to a point where it's a lot easier to do. It's a lot more commonplace, and certainly a lot more important anymore. The more motors, more VFDs, more servo drives we're putting in, the more important it is that we take the time to do that engineering and kind of design around these things so that we can incorporate it into all sorts of machinery. There's a lot of machinery that can really benefit from that type of technology.
Absolutely, absolutely. One thing I'd like to do, if you don't mind going here, is I'd like you to share what some of the back off products you're using. So we've never actually had a back off product overview. So being as somebody who's actually doing these systems, what are they have a huge product line. What are the products you're using on these projects you're doing?
Sure. So there's quite a few of their products that we utilize directly. Um, namely at the heart of it all, their IPCs have been a really key piece for us because it really helps. I'll step back. The way that they've created their ecosystem with their licensing structure and their capabilities within their IPC package make it very seamless and very easy to integrate a lot of advanced, very rich features into a machine. So we don't have to commit to all of it up front. With their IPCs, we can say, hey, I know I want to do 5 axes of motion, and I know that someday I may want some really high speed synchronization capabilities and camera capabilities and energy monitoring and theater and navigation control with that. But we don't need to purchase all that up front. We can simply have that functionality sitting dormant and then roll it out later. So it kind of starts at the head with their IPC. And then from there, we typically accessorize that with a number of different things. One of them being their integrated safety, especially when we get into talking about servos and VFDs and large format motors. Their integrated safety platforms kind of the next key step to all that. And then moving on from that, a lot of what we're using in our current machinery bills is we've got one active out in the shop right now and a couple more coming up here in another month or two. What we're using a lot of is their entire servo package. Really, really cool system, the way they've designed it. We've used a lot of different competitors' servos over the years, too numerous to mention, but a couple of key points to the backoff system that's really got us on board there. It's, oh my gosh, this is kind of game changing and really nice for us. One, the compact nature of it. They've got these really small format dual channel drive modules, single channel drive modules. typical to a lot of different manufacturers out there. They have a system where it's modular with one master power supply that can drive a multitude of servos or independent drives. And then furthermore, they accessorize that with capacitor modules that can go on that bus to help with that energy storage that we mentioned. And then one of the coolest modules, my favorite, that I have begun to throw in every new cabinet design, every new build we do is what they call their AX8820, which is their regeneration module. Um, it directly couples back to that 480 bus coming in. So whatever three-phase 480 you've got coming in, we're connecting to that. And it allows us, if we exceed our bus capacitance and we can no longer store, allows us to then take that energy, dump it back onto the grid into some really cool things like we're shown on the touchscreen behind us here, where customers love this. And it's not only a great sales tool, but it's environmentally friendly. It's it's something that helps them utilize some of these different tax incentives that are offered out there, both regionally, statewide, federally. And basically what that is, it allows us to demonstrate how much energy this machine has saved over its lifetime. So we can then, long-term graph that data, long-term store that data for them, and actually put it on the screen and make it available so that their team can see and represent, hey, this machine over the past year with the number of times that it started and stopped has saved us, $5,000 in its operation, which is pretty substantial for some machinery. Now, obviously, that it scales differently. It's going to change for a small two-servo system. You're probably not going to see anything, upwards of $5 to $10 a year in savings. But you get into machines like some of these that we work on in the printing web industry, that's 40, 50 sound servos.
Hey, everybody, just want to break in here really quick and thank Landon for sponsoring this episode of the show so I can bring it to you completely ad-free. If you have any projects you think Landon would be a good fit for, please give him a buzz. He's been doing this for a very long time, and as you can see from this podcast, he does a wide range of different applications. I also want to mention that if you want to come get some training from yours truly, or maybe you have somebody who works for you who needs some training, I do have a class coming up very soon, so check out theautomationschool.com for details about that training. And with that said, let's get back into this week's episode of the Automation Podcast. Yeah, and I think when you started explaining what the products you're using, you said IPC multiple times. And I think that's one of the big things that other vendors, when you think of an IPC, it's like an HMI, right? That sits in a panel, but it's a PC, right? And so to Beckhoff, their IPCs, I think usually when I look at their PLC page, when I go to the Beckhoff PLC page, everything says IPC. So am I wrong about that? But when they say IPC, it's actually their IPC that runs their control engine.
Sure. Yes. And great point. I think, if you'd asked me that question a year ago, I probably would have answered with PLC and not fully adopted the Beckhoff ecosystem of the IPC terminology. But yeah, in their world, nearly every product they make in the control segment, what we have traditionally called PLCs, they're calling everything an IPC from their perspective because it is effectively PC based. So it's not limited to just HMIs. We've got some up on the wall behind us here that it may be a little difficult to see in the frame, and we can zoom in on some of those after a bit, get a little better shot of them. But one of their greatest units, I've got 7 of these things here at our shop, and I think we've got 5 of them out in the field now. They're what they call their C6017 is an IPC that has all the PLC functionality. It's a Windows-based PC. It's got 4 dedicated gigabit NIC ports built into it, high definition video output, USB ports, but it's a real powerhouse. It's a multi-core processor, can be ordered. This unit in particular has 4 cores and a built-in UPS in it. So little brownouts and power fluctuations don't affect it, but a real powerhouse in comparison to the traditional format PLC we might see. Same physical size, the physical size isn't much different. In this case, maybe even a little bit smaller than some that we may be used to for your typical motion capable PLC. But yeah, real powerhouse. That term kind of becomes interchangeable once you enter into this ecosystem. So.
Yeah, can you explain to me, this may not be a fair question, but I've always struggled understanding, so there are a lot of vendors out there who are who use the CodeSys as the engine. Some of them just use the plain CodeSys developer. Some of them have their own branded version of the CodeSys developer, and sometimes they throw some extras in the software because they're taking the code from CodeSys and then putting in, their extra pieces and parts. Do you know,
Sure.
and again, this may not be a fair question, but can you explain to me what is the difference between the programming and I don't even know what it's called. I think it's called TwinCat, but what is the programming software for Beckhoff, and is it different than CodeSys? Does it have more things? I mean, can you explain that?
Yeah. It's a great question. I'm going to do my best with it. I hope I do my friends at Beckhoff proud here and don't say anything I shouldn't. But yeah, their development environment, their IDE is a little unique. I'm familiar with some of the ones you're talking about. We started with some of those CodeSys adaptations, some of those vendors ages ago. Um, this one's pretty unique. So TwinCat is the development environment. That's it. You had that one right. What they did, they took Visual Studio and they adapted that. So they have they've got two variations of their IDE. They've got one that can natively live within an existing installation of Visual Studio. So if you're someone who's grown up with Visual Studio and spent a lot of time programming in that environment, you can simply add the TwinCat extensions to it, and now you're good to go. But they've also created another standalone one for maybe some of us more factory-oriented folks who haven't grown up in the Visual Studio environment. It's still based off of Visual Studio, still uses that as its core, and has a lot of things borrowed from the CodeSys IDE. You certainly, if you grew up with CodeSys, you'll see a lot of things that look very familiar, but you also see a lot of things that throw you off, and you'll say, "What is this? How do I do this? Why is maybe for some of those who are familiar with the Control F5 to write temporarily write a value, those things aren't carried over, so you don't have some of your same shortcuts and what have you that you may be accustomed to from some of the other IDEs. Um, but it's a blending of those things. So blending of Visual Studio, blending of CodeSys, and then some very unique items that are specific to Beckhoff. So things like their EtherCAT bus browsing utility. Oh gosh, what else could I throw in there? Yeah, they've got a lot of their vision functionality, uh, direct ability to write code in C++. Oh man, their motion configuration utility. Another one of the really great things that helped us to fall in love with their product was the fact that unlike some other vendors where we have separate softwares that we need to utilize to configure a VFD, to configure a servo drive, to configure other accessories that may sit on the bus, they've done a great job of wrapping it all into one software. So you're not going to their website and downloading multiple utilities. You're not having to do multiple installations. You're not having to do a lot of that accessorizing in order to get everything set up. It's just there. It's all right in that one IDE. So it's easy to drill in and it's easy to take an existing project when that client calls 6 months down the road and says, "Hey, remember that quote you sent us for the vision system? We want to go ahead with it." Well, now instead of kind of starting over and trying to integrate that into your existing code and having to map variables over, it's all right there. You just go to the vision tab and say, add scan camera. Let's rock and roll. We're good to go. So kind of a cool feature of it is all that sort of nested behavior of all their different product line is pretty well covered under that one software.
And thank you for explaining that. And it makes sense that EtherCAT that would be their preferred network, I imagine. And so, yeah, they would want to have that browser built in. They want to have their catalog of hardware built in too. That can be frustrating with some third-party systems it's using this universal system, but you have to add their hardware in. It's not intuitive. I imagine they have their hardware catalog built in. One thing I want to ask, and it seems like every time I've ever seen TwinCat or Beckhoff, is everybody's using structured text. Is that what you're finding? Because I know some end users don't like it because it's harder for the electrical folks to understand. Electrical folks aren't programmers, right? In many cases, they don't want to learn structured text. So, what has been your experience in using the product over the years and the different languages?
Yeah. So that's where that kind of borrowing from the CodeSys IDE lends itself to be rather helpful, right? I'm a structured text guy. Happy to dig into any LD stuff out there and work with Ladder quite a bit. But I'm a structured text guy, but I certainly get where you're coming from. And yeah, they've maintained that CodeSys functionality where we can go into the IDE, we can still do function block diagram, we can still do all the CFC or ladder diagram programming. So there's still, of course, the I/O adaptation portion of it that gets into more of the EasyCAD element. However, that familiar ladder programming and SFC programming, that stuff is all still there. So you can do both simultaneously, just like traditional CodeSys would allow us to have both side by side. Maybe I have a little structured text and a little ladder and a little bit of everything. You can do both. You can hybrid program within the environment. So out of that, it's still there.
Well, I appreciate you asking because, yeah, I haven't had a chance to talk to anybody who's actually using it like you. So it's good to get that feedback right from the field on how you're using it, how you're deploying it. What other, if you don't mind me asking, what other interesting applications have you been working on? I know we talked a lot about energy savings and, common bus and regenerative products. What are some of the other interesting things you've been working on lately?
Yeah. So we work on a couple of cool different projects over the past couple of years where what we've been trying to do is for a lot of these clients is some of them who have some of those same systems you just mentioned, also bringing out and utilizing some of this technology, especially given the IPC's Windows-based architecture, lets us build some pretty advanced HMI servers. So when we've got clients who have a demand to see this energy information or want to see their production numbers and get some of that SCADA type data pulled out rather than having to go to third party vendor. Again, we've got functionality built in where it's like, okay, I can serve up as many different web pages as I'd like off of one of these IPCs, and I can have it in a general sense that almost unlimited clients access those pages. So instead of just having one HMI screen or a couple HMIs on a machine, now every computer terminal within the plant or within the plant manager's office, production managers, anybody involved in the operation can now have access to these web pages that may or may not be unique to the actual machine that the IPC sits on. So an IPC kind of no longer has to be something that's real specific and geared toward just the machine it's installed in. It can function as this greater web server that allows us to push some data out, give a little bit greater visibility to the production environment, and prevent us from having to install ancillary equipment to handle those tasks. And that's something we've actually invested quite a bit of time in, a lot of energy in. One of those dashboards is actually up on the monitor directly behind me, and to the top here, that's some live plant data from some great customer and good friends in Ohio. They've got about 14 machines up and running right now, and that shows them all their active production data, what jobs they're running, how fast the machines are going, how much downtime they've had on those machines. And that's all pushed off of back off IPC.
It's awesome. So it's more on the production level side where maybe the manager wants to know, how the machines are running. Are they running effectively, efficiently? Are they producing the products in a timely manner? Are they all up? Are they down? So I think that makes a lot of sense. What about alarming? Have you done a lot of alarming with these systems? I can definitely see that on the engineering side, people are going to be like, I need my alarms, right? I need to know if something's going wrong. I need to know, need to be descriptive, right? So a lot of
Yeah.
times we want the operator to be able to solve the issue. Maybe there's a jam. Maybe something needs to be adjusted.
Yeah. Yeah, we have. It's kind of a there's I'm going to make that a twofold answer because there's kind of two sides to that. There's our traditional alarming that you and I would probably think of as we've seen with any HMI out there, where we have that ability to roll up an alarm screen somewhere and have historical alarm trends, active alarm information, whatever you displayed. That functionality, yeah, we do by default always build that out with every machine we're putting together and have that functionality. But one of the cool aspects of the Beckhoff HMI platform and their hardware platform, it lets us take it a level deeper where with a simple drag and drop, we can also put in a full bus architecture explorer. and we can click in and drill into different levels of the bus architecture as we go. So if we've got 100 servo drives and we've got a couple thousand IO that are covered across several hundred IO modules scattered about a machine or about a plant for that matter, we can walk up to an HMI and we see that, okay, we've got an alarm, the bin is full, but we went and verified the bin is empty. What's going on? We can now drill in through our IO tree and say, okay, the IPC is fine. It's communicating with that remote IO. The IO module is functional. Oh, I see here, it's an IO link sensor that we've got on there. Our IO link sensor is malfunctioned. And we can easily drill down, in a very visual sense where it's real easy to understand. It's not looking at some cryptic alarm cataloging that maybe we came up with ourselves as the engineer on the system, rather than having to understand, well, what's this alarm code 230? What does that mean on this VFD or on this sensor? We can literally visually see exactly the issue that's present and drill into all those different elements of the system, which is really kind of cool. So yeah, we're doing alarming kind of twofold with these systems. Usually the way we present that is that traditional alarm banner at the top. You click the banner, you can go to the long-term alarm log and scroll through and see what all you've got. But then we also provide, that further option where, okay, now let's get a little deeper. Let's dig in and see, is there something wrong with the IO? And whether or not that's directly helpful to an end user of a machine or not, certainly helpful to us when it comes time for that remote troubleshooting call, when the customer calls and says, hey, I don't know what's going on. And you say, okay, let's go to this screen, click here, show me, is everything great? Oh no, I've got one that's red. Okay, which one's red? And now, it used to be a lot of systems. We'd had to bust out our laptop, log into the remote gateway, log into the system, and acquire that information ourselves. Now we can kind of direct the end user, the client, to walk us right to that without even, sitting in the airport lobby, say, okay, hey, click here, go there. What's it say? Okay, that IO module's failed. So
Yeah, that sounds good. Um, was there anything else we wanted to, I'm just looking at the time here. Was there anything else we wanted to cover in this episode? I know we've covered so much already, but was there
sure.
anything else on the list of things we wanted to touch on today that you wanted to cover?
So yeah, Sean, something that you and I hadn't spoke about previously that I'd been working on kind of in the background was a partnership with a company called SiteIQ, who helps us take all of this technology yet again one step farther. And our partnership that's underway with them helps us to take and store all this data we talked about, all this information from alarms to machine speeds to power consumption of the whole facility, power consumption of individual machines and their performance, and bring that out long-term data storage in a cloud where clients can access it and really produce actionable data from it, right? Because a lot of times these bare numbers that we've got on the screen, our power factor and our kilowatts consumed, they might mean something to us as engineers, but they don't necessarily mean something to someone in the boardroom right off the bat. So that was kind of one of the last things that we had done is say, okay, what do we want to do with this to really make it actionable information? And SudIQ's helped us with that. They've kind of helped us take that data, pull it out, bring it into long-term storage, and give the boardroom folks something that they can act upon, something that they can make educated decisions on and say, okay, this one machine or these couple machines that we have from 1978 are really starting to be a draw on things here. They're not really being super productive. What can we do to improve that? It completes that full loop for us where we can help them stay engaged and help them make better, more qualified decisions on what are they going to do with this equipment. Does it make sense that we come in and upgrade it? Does it make sense they have a new OEM come in and replace that equipment with something more modern? What's the next logical step? And they offer some cool features. They also integrate within their single dashboard. They integrate digital twin. They integrate smarter preventative maintenance stuff. They also manage fleeting robots. So it kind of for us, it felt like a natural jump. Like, how do we complete this whole picture, and how do we offer something to everybody that's really, just complete package from soup to nuts? So,
Very interesting. Site IQ. I'll have to keep that in mind and check that out. I guess we should probably end with a discussion of how people can get in contact with you. What's your social media, and I'll try to put up for the people watching. I'll get a slide and put it up on the screen at this point. But for those people who are listening, can you run through all your information again, Landon?
Sure, absolutely. So our website, it's my name, LandonDescamps.com. Via our website, you can find all our contact info and socials. We're on LinkedIn, we're on YouTube, phone numbers on there, some email and intake contact forms on there if anybody's interested to learn more about energy savings in the industrial environment and some of the other services we offer. Yep, be happy to have folks reach out with any questions.
That's awesome, and I really appreciate you coming on. I learned so much about, what you do, and it was great talking about energy savings too, but also learned a lot about the platform you're using, which is Beckoff, and just really appreciate you sharing that information with us. And if anybody out there who's listening or watching, if you have questions, please don't hesitate to get in touch with Landon. He's, as you can tell, just real easy to talk to, and he's working on this stuff every day. So if you have a project you want to talk to him about, please reach out to him. And with that, Landon, thank you again for coming on the show. Really appreciate it.
Likewise, Shawn. Thank you very much.
Well, I hope you enjoyed that episode. I want to thank Landon for coming on the show and talking about all the different products he's using. He's one of the few people I've actually had on the show who use Beckoff. So it was great to hear about all the different things that Beckoff is doing out there. And hopefully we'll get them on the show in the future. But if you have any projects that you think Landon would be a good fit for, please contact him directly. Also, if you know anybody needs training, please check out theautomationschool.com because I have a training class coming up very shortly. So please check out the schedule up there as well. And with that said, I want to thank you all for tuning in. I want to wish you all good health and happiness. And until next time, my friends, peace.